Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science paper, chemistry paper, foundation tier, paper 2 from 2023. Question number 4 is on the topic of the rate and extent of chemical reactions. A catalyst is used to increase the rate of decomposition of hydrogen peroxide. So decomposition, what does that mean? Decomposition means to break down. So decomposition means to break down. Hydrogen peroxide decomposes to produce water and oxygen. Write a word equation for this reaction. So they have given you just one line, so that's hydrogen peroxide. To produce water and oxygen. Now, hydrogen peroxide is a reactant. And water and oxygen are the products formed. Now, if you want to write a word equation just as revision, hydrogen peroxide is H2O2, which is a liquid, gives water, which is H2O, again, which is a liquid, plus oxygen, which is O2, which is a gas. Now, you don't really have to balance this. Actually, you can balance this equation. So there's 3 oxygen, 1 over here, and there's 2. So there's only 2 oxygen. So if I add, let's say, 2, that makes it 2 there, 4 hydrogen and 4 hydrogen, 4 oxygen on this side, and there's 2 oxygen plus the 2 oxygen. That will make it balanced. Right, let's go into the equation. Question. A student investigated the rate of decomposition of hydrogen peroxide using 3 different catalysts: manganese dioxide, copper oxide, and zinc oxide. Figure 7 shows the apparatus used. So here you have a conical flask and the catalyst and 25 centimeter cube of hydrogen peroxide, and the entire thing is attached to a gas cylinder. So when you mix the catalyst with the hydrogen peroxide, it's going to break down to give oxygen, where you see as the bubbles of gas given out, and that gas is going to get collected over here in the syringe. So you can measure the volume of oxygen that's actually generated. This is the method used. Measure 25 centimeter cube of hydrogen peroxide solution into a flask. Add 0.5 gram of manganese dioxide catalyst to the flask. Attach a gas syringe to the flask. Measure the volume of oxygen produced every 20 seconds for 120 seconds. Repeat steps 1 and to 4 2 more times. So every catalyst, manganese dioxide, they're doing it 3 times. Then they're repeating it with copper oxide and then with zinc oxide. Which 2 control variables, right? So 2 control variables, right, were used in this investigation. So control variable is what you don't change, what you keep the same. So the mass of catalyst used, which was 0.5 grams. Shape of the flask, that doesn't actually affect the rate of the reaction. Time of taking readings, not necessarily. Volume of hydrogen peroxide, yes, because they're using 25 centimeter cube all the time, right? Oxygen gas, that depends on the catalyst and the time. So while we're here, Remember, there are two other types of variables. Dependent variable is what you measure. So in this practical is the volume of oxygen. Independent variable what you change, that is the type of catalyst. Right. So let's have a look at question 4.3. Table 3 shows the results with manganese dioxide catalyst. So time in seconds is going up in 20s up to 120. Volume of oxygen in centimeter cube is also increasing, but it's not increasing step by step, but generally it's increasing from 0 to 50. This is for manganese dioxide. Figure 8 shows a graph of the results with copper oxide catalyst and with zinc oxide. So they've already are showing you the lines for copper oxide and zinc oxide here. 4.3, complete figure 8. You should plot the data for the manganese dioxide catalyst from table 3. Draw a line of best fit. The first 2 points have been plotted for you. So you've got 0 and 20 already plotted over here. So let's have a look at what is 40. Let me see if I can bring that into use a bit. Yeah, just about. Yeah, there you go. So for 40, it's 32. So each of these boxes is actually 2 centimeter cubes in volume, because there's 5 boxes for 10. 10 divided by 5 gives me 2 centimeter cube. So each box is 2. So I need, at 40, I need 32. So it's going to be that. And 60 is going to be 40. At 80, it's 45. So it's halfway between 50 and 40. And at 100, it's going to be 49. So it's just below 50. And 120 is 50. Right. So the total marks available is 3 marks for this question. So plotting the points correctly should give you 2 marks. And drawing a line of best fit should give you the 3rd mark. Now, line of best fit needs to be a curve going all the way like that. It can't be, it can be a, they have drawn a straight line, but the points that we have actually come up with is actually the way it's falling is not a straight line. So I would actually draw a curved line. Which is the best catalyst? So give a reason for your answer. Is it copper oxide, manganese, or zinc oxide? So as you can see, the line for manganese dioxide is the highest, or you could say it is actually the steepest. So manganese dioxide, they have all been added 25 centimeter cube of hydrogen peroxide. So it's producing the most amount of oxygen. And it's also producing the most amount of oxygen in a shorter time. So in 40 seconds, manganese dioxide has produced actually 32 centimeter cube, whereas zinc is producing about 3 and copper is producing about 6. Right? So manganese dioxide is the best catalyst. Reason, right? It has the steepest curve or you could say produces the most oxygen in a given time. The student repeated the investigation with manganese dioxide catalyst. The results were all close to the true value. True value is what you're expecting it to be, what it should be. So they were all close to the true value. Results that are close to the true value are accurate. The student repeated the investigation using manganese dioxide catalyst at a higher temperature. Complete the sentence, choose the answer from the box. At a higher temperature, the rate of reaction will increase. Remember, there's a couple of things that will increase the rate of reaction. One of them is temperature. That brings us to the end of question number 4, and I will see you in question number 5.